Imagine spending like 4 hours tracking down this really critical software bug. You document everything, you send the report off to the engineering team, and 10 minutes later, you get a three-word reply that just absolutely crushes your soul.
Oh, I know exactly what you're going to say. Could not reproduce.
Yes, could not reproduce. Today, we are eliminating those three words from your professional life forever. Welcome to a very special masterclass edition of the Deep Dive.
It really is the ultimate roadblock, isn't it? And, when a developer says they cannot reproduce an issue, what they're really communicating is, I can't follow the path you laid out.
Right, exactly.
So today's deep dive is basically a masterclass in fixing that exact breakdown in communication. We're looking at a pretty brilliant presentation from QA Dojo.
Yeah, specifically Module 4, Lesson 14, right?
That's the one. It's created by manual QA tester in Kiru, who also goes by Justy. And the entire focus is mastering what the industry calls reproducible steps.
And to get there, for everyone listening, I want you to visualize a pristine diagnostic laboratory.
I love that visual.
Right. In this space, every chemical is perfectly labeled, every measurement is verified, and the whole environment is entirely objective. There is zero room for guesswork.
Because the goal today is to take your messy, private notes, those rapid-fire thoughts you jot down in Jira when you're working fast, and transform them into precise professional artifacts that actually belong in that pristine lab.
Okay, let's unpack this core problem first, because before we can even start writing a flawless bug report, we have to fundamentally redefine what a step actually is in this context.
Right, it requires a pretty massive mindset shift.
Because I think a lot of us just assume that a step is, a record of what we did.
Which is the exact assumption that leads to those dismissed bug reports.
Wait, really? Just writing down what I did is the problem.
Yeah, the core concept we need to establish right now is the strict definition of reproducible steps. A reproducible step is an instruction specific enough that two completely different people, acting entirely independently, perform the identical action and arrive at the identical state.
Okay, two independent people. So if I can translate that to like a broader professional environment, it's like writing a pull request or a handover document that relies on invisible knowledge, right?
Yeah, exactly.
Like if I tell a new hire, just run the standard database migration. That assumes they know what standard means, which directory the scripts are in.
Which environment variables they need.
Exactly. They're essentially flying blind.
And that blindness is what causes the whole chain reaction of failure. Because to the person who wrote the instruction, run the standard migration makes perfect sense, right? It relies on their private memory of having done it 100 times.
Right. But to a stronger.
If there's a stranger or a developer trying to fix a bug in a system they didn't even build, it's utterly useless. The source material draws a very hard line here. A step that only you can follow is just a private memory. A reproducible step is a professional artifact.
So does this mean the solution is just like sheer volume? If I'm testing a complex checkout flow, should I be writing a detailed, multi-paragraph essay for every screen?
Well, no, that's actually the most common trap beginners fall into. When they try to be detailed, they just write more.
Oh, interesting.
Yeah, flooding a ticket with extra conversational words usually just creates more friction. It's not about volume, it's entirely about precision. It's about removing every single place where a reader has to make a choice or a guess.
Right.
And Kiru puts this beautifully in the presentation. There's a quote that serves as the guiding philosophy for this whole masterclass. Your absence is the ultimate proof of a perfectly written step.
Oh, wow. Your absence is the ultimate proof. I love that. So if you just magically disappeared from the company Slack right after hitting send, the developer should still be able to trigger the bug.
Exactly. Without ever needing to schedule a quick sync to ask for clarification.
Okay, so let's do a quick mini summary checkpoint here before we move on. To sum up this first mindset shift for you listening, a step that relies on your personal context is just a private memory. But a perfectly reproducible step is an objective artifact explicitly designed for a total stranger to execute.
Spot on.
So, with that mindset locked in, let's look at the actual biological makeup of a step that leaves zero room for guesswork. The QA Dojo material visualizes this as 5 interlocking structural pillars.
And this is important. This isn't a menu where you pick 2 or 3. Every single step you write must be built on all 5.
So the structural integrity fails if even one is missing.
Precisely. So the very first pillar is that your step must be atomic.
Atomic.
Meaning it does exactly one thing. You never, ever hide 2 or 3 distinct actions inside a single step.
See, here's where it gets really interesting, and I want to push back on this a little bit.
Go for it.
Because this is where the friction happens in the real world, right? If I'm auditing an e-commerce site, breaking every microscopic mouse click and keyboard input into its own atomic steps sounds exhausting. Why can't I just write, log in as an admin and navigate to the dashboard?
To get it, it feels tedious initially, but we have to look at the psychological mechanics of debugging. The lesson provides this great workflow diagram, the lifespan of a test step. Think about the branching paths of that flowchart. When a tester writes a bug report step, the immediate question a developer asks is this perfectly reproducible? If you bundle actions by writing log in as an admin, you force the developer to assume context.
Because login as an admin hides like a dozen micro decisions.
Exactly. Are they using a specific test account? Are they logging in from the home page or a direct portal link? Are they bypassing two-factor authentication?
Ah, I see.
Because you bundled all those actions into a casual phrase, the developer has to guess. They try their own normal admin login, it works fine, and suddenly your bug is dismissed.
Wow, so all your hard work finding the issue just evaporates because they couldn't follow your exact path.
Right, but if the step is atomic and exact, the developer follows the identical path, the bug is credible, it gets verified, and it gets fixed.
Okay, so the step has to be atomic. Let's say I break it down and I write, the submit button is clicked. That's a single action.
It is a single action, but it violates the second pillar. It must be, the submit button is clicked is passive. You have to use a direct command leading with an action verb. You're telling the reader exactly what to do. It needs to be click the submit button.
But even that introduces ambiguity, right? What if there are like 3 different submit buttons on the page? One for a newsletter, one for a form, one for search.
Which brings us directly to the third pillar, specific.
Ah, okay.
You have to name the exact element on the screen, the specific field, the specific button, or the exact value you're entering. You wouldn't say click the submit button, you'd say click the subscribe to newsletter button. No vague references allowed.
And naturally, if we have these hyper-specific atomic commands, they need to be ordered, which is the 4th pillar.
Exactly. They must be numbered in the exact sequence they occur. Chronology is the only way a developer can recreate the state of the application.
And the final 5th pillar is that the step must be self-contained.
Yes, and this directly addresses the cognitive load on the developer. A step should include the necessary data inline, or it should point clearly to a dedicated test data section.
Right, because you want to avoid that awful context switching cost. If a developer is reading like step 7 and they suddenly need a specific 24-character testing token, they shouldn't have to scroll through 3 pages of comments to find it.
And that frustration is exactly what gets your ticket pushed to the bottom of the backlog. You have to provide the data right where it's needed.
So to do another mini summary checkpoint here, to guarantee an engineer never has to guess, every single step you write has to follow these 5 structural rules. It must be atomic, imperative, specific, ordered, and self-contained.
Perfect summary. If it fails even one, the whole structure collapses.
Okay, but having that 5-part structure is only half the battle, right? Because a perfectly structured sentence is still completely useless if the vocabulary you put inside it is vague.
Right. This is where we transition from structure to syntax.
The language rules. The QA Dojo course spends a lot of time focusing on eliminating what they call anti-patterns, which are essentially just bad habits we pick up from casual conversation.
Exactly. Language conventions are where you truly sanitize the instruction. The first major rule, Nkiru highlights, is the strict use of platform-correct verbs.
This is a fascinating nuance, because in normal conversation, we use these words totally interchangeably. People say, click this link on your phone all the time.
We do, yeah. But in a professional QA environment, verbs have rigid, technical definitions. If you're testing a mobile application or a touchscreen, the correct action verb is tap.
Tap.
But if you're on a desktop using a mouse, the correct verb is click. You must never mix them up.
Let's dig into why that matters, because it might seem, I don't know, overly pedantic to a beginner. If I write click the menu icon on a mobile bug report, the developer probably still knows what I mean, right?
Well, they might guess what you mean, but you've just introduced doubt. Think about how modern software is actually tested. Developers frequently use desktop emulators, like Chrome DevTools, to simulate mobile screens.
Oh, right.
So if a developer reads click the menu icon on a mobile bug report, they might pause and wonder, wait, did this tester find this bug on an actual physical iPhone using their finger, or were they clicking around on a desktop emulator?
And if the bug only triggers on actual touch-based events, but the developer tries to recreate it using a mouse click on an emulator, they won't see the bug.
And there we are, right back to could not reproduce. Doubt is the absolute enemy of reproducible steps. Using tap instantly communicates physical mobile hardware. Using click communicates a desktop mouse. The precision of your verb tells a story about your environment.
That makes so much sense. Okay, the second language rule focuses on using a present tense imperative. So you always use direct present tense commands. Enter, select, scroll, tap.
Right. You never write a narrative of what happened to you in the past. You're not writing a diary entry saying, I clicked the checkout button and then the cart crashed.
Right, you're writing a script for someone else to act out right now. 1, click the checkout button.
Exactly. And the lesson provides this comparison matrix that illustrates this perfectly. It puts a vague anti-pattern right next to a reproducible fix.
Yeah, let's look at that bad, vague example for testing a login failure. The anti-pattern says, try logging in with wrong details and see what happens. Right? Just hearing that read aloud, you can feel the ambiguity dripping off it.
It's a nightmare of an instruction. It fails almost every single rule we just established.
It's totally packed with judgment words. Try. You don't try to do something in a structured test, you execute it. And see what happens is a completely subjective phrase, not to mention what on earth does wrong details even mean?
Well, exactly. Wrong details forces the developer to invent their own test data. Do they use an email that doesn't exist? Do they use a real email but a wrong password? Do they leave the fields blank? You're forcing them to guess.
Right.
Now compare that to the reproducible fix Incure provides. Step 1, navigate to log in. Step 2, enter quasar@demo.com in email. Step 3, enter wrongpass99 in password. Step 4, click login.
It's like night and day. It's an entirely different dialect of English. It's atomic, it's specific, and it's imperative. And notice how the fix specifically names the UI elements. Inkiru writes, enter in email, enter in password. It isn't just like type your email in the box. You name the exact field as it appears in the code.
There's another incredibly common beginner mistake, highlighted in the diagnostic checklist portion too. It's the habit of using the word observe as a user action.
Oh, I am so glad they called this out, because I see this in documentation constantly. You'll be reading a list of steps and suddenly hit step 5, observe the error message.
Yeah, it feels natural to write, but logically it's completely flawed. Observation is the result of a step. It's not an execution that a user performs.
Right.
You perform a physical action like tapping a screen, and the system responds. You state exactly what the system's response should be, but observe isn't an action you take with your hands on a device.
You have to keep subjective judgments and passive observation completely out of the active step sequence. So, for our third mini-summary checkpoint, mastering QA syntax means deploying platform-correct verbs like tap and click, strictly using present tense imperatives, and brutally stripping out vague judgment words or passive observations.
So now we have the structural anatomy, and we have the precise vocabulary. Now we need to see what happens when we assemble all of these microscopic elements into a macro-level, real-world bug report.
Because this is the exact moment where you build professional trust with engineering teams.
Absolutely. The course provides this brilliant, comprehensive worked example. They deconstruct a bug report for a feature called the stay-in-the-loop form.
The bug itself is relatively simple, right? The newsletter form is accepting fake, improperly formatted email addresses.
Right. But the very first thing this bug report does, before it even gets to step number 1, is establish the exact starting state of the application. This is called defining the preconditions.
This is so vital, because you don't want to waste an atomic step telling a developer to turn on their computer and go to a specific website. You set the stage first. The preconditions in the example clearly state, 1, user is on wanderings.skill-wanderer.com, and 2, scroll to section.
And once the starting state is universally understood, the steps to reproduce actually begin. 1, scroll to the subscription field. 2, enter a non-existent email. 3, click subscribe.
And notice how the test data is handled here. The specific fake email they use, anyabinimenk@gmail.com, is kept in a totally separate but clearly linked section called test data. You don't clutter up the sleek, active step with a 30-character email address.
Right, you keep it self-contained but visually clean. Now we get to the most critical distinction in the entire report.
Yeah.
How we state the core issue.
This is where we deploy the terms expected result versus actual result. And even before you flag the severity of a bug, you have to prove it exists using these results. Your active steps, the scrolling, the clicking, the typing, those must remain completely neutral. You simply describe the path. You describe the bug separately, down in the results section.
Yes, the expected result is what the software should have done according to the design requirements. In this case, the form rejects the invalid email.
And the actual result is the bug itself. It's the reality of what the broken system actually did. The form accepts the invalid email.
By rigidly separating the neutral execution steps from the actual result, you create an objective, verifiable artifact. The developer walks to the neutral path, and they witness the actual result themselves.
If we zoom out for a second and look at the bigger picture, why are we being this rigorous? Why are we analyzing verbs and separating data streams like we're writing academic papers?
Because, as the source material lays out in this really fascinating graphic called The Timeline of Building Professional Trust, reproducibility is not just a nice-to-have skill. It's the entire underlying currency of a QA tester's career.
Right.
It's the fundamental unit of trust, especially if you're working in the freelance or remote QA economy.
The timeline really shows this professional evolution. When you're just starting out, it begins with passing reviews on platform-based testing sites like Test.io. You survive those early reviews by rewriting your vague, messy notes into strict atomic steps. But then you level up.
Right. You start attaching these highly structured, perfectly reproducible audits to your upper proposals. Before a client even hires you, you submit a sample bug report that is so undeniably precise they can reproduce the bug in 5 seconds. You prove your rigor up front.
And it culminates in the highest tier of freelance work, which is cold outreach. Hooking startup founders or lead engineers with one perfectly reproducible, verifiable bug. You send them an email with an issue so clearly written they can replicate it instantly on their phone while drinking their morning coffee.
That is how you win high-paying clients.
Yeah.
Because it's evidence so solid that no one needs to take your word for it.
Yeah.
You don't need a resume if you can pave a flawless path straight to a critical failure in their system.
So to wrap up this final segment for our fourth checkpoint, a professional bug report always uses preconditions to set the stage. It relies on neutral atomic steps to pave the path, and it clearly contrasts the expected result with the actual result to prove the existence of the bug.
We've covered an immense amount of ground in this masterclass, transforming how you fundamentally approach instruction writing. Let's synthesize this into the daily workflow of a professional.
Let's picture a top-tier QA tester sitting down at their desk tomorrow morning. When they find an issue and open a ticket, they're actively applying the 5 key takeaways from QA Dojo. First, they apply the ultimate test. They look at their ticket and ask, could a total stranger follow these instructions and land in the exact same broken state without my help?
Second, they audit their own writing against the 5-part anatomy. They ensure every single step is atomic, imperative, specific, ordered, and self-contained.
Third, they enforce the language rules. They verify they're using platform-correct verbs, remembering the massive difference between tap and click, and they only use present-tense imperatives.
Fourth, they hunt for anti-patterns. They ruthlessly edit out bundled actions, they delete subjective words like try or observe, and they never assume the reader shares their context.
And finally, fifth, they separate the bug. They clearly define the preconditions to set the stage, they keep the action steps entirely neutral, and they prove the failure by clearly contrasting the expected result with the actual result.
As Nkiru states on the final slide of the presentation, precision is a habit. It isn't an innate talent you're born with. It's a mechanical muscle you have to flex, tear down, and build back up. So the call to action for you, the learner, is to practice this today.
Yes.
Write a reproducible test step for something completely mundane like logging into your bank or ordering a coffee on an app using all 5 pillars.
I want to leave you with a provocative thought to chew on as you go practice. We've spent this entire deep dive talking about removing human guesswork to make your writing perfectly objective. But think about the trajectory of software development right now. If you master reproducible steps, you are essentially writing a highly structured, logic-based script in plain English.
Oh, that's a really good point. Right.
How long is it going to be before an AI agent can simply read your perfectly atomic, perfectly specific bug report, navigate the application itself, reproduce the actual result, and then just write the patch autonomously?
Wow. Not long at all.
By mastering this level of precision, you aren't just communicating better with developers today. You might be learning the exact syntax required to command the automated engineering teams of tomorrow.